Very good afternoon to all. Today we are going to discuss about the robotic control system in depth along with the dynamic equations. Actually, we can classify the robotic control system into three categories. One is model-based control, another one is trajectory-based control, another one is task planning. So path planning or task planning based control. Okay, so based on the industrial type of control, we can classify point-to-point control, continuous path control, controlled path control, then stop to stop. So we can classify robo into four groups. Okay, first one is point-to-point, other one is continuous path control robo, then controlled path control robo, stop to stop. Okay, what is point to point PTP? Okay, point to point control robo. So the point to point control robo is capable of moving from one point to another point. The locations are recorded in the control memory, the robotic control memory. Okay? So the locations where we have discussed on the path planning, different type of trajectory. Okay, so smooth trajectory and quadratic and polynomial path planning. So the point-to-point robo do not control the path to get from one point to another point. Okay, another point to next point. So repeatedly doing. The common application for this include component insertion, spot welding, hole drilling, machine loading and unloading applications. Finally, assembly operations. So these are all based on the path and task planning control of robo. One more is how we can control the robo to reach the desired position and desired velocity and its desired dynamic. So that in depth with the dynamic based control system, model based or trajectory based control system. Say today we'll discuss in brief about the different type of control techniques. Welcome. So this is a very important topic. So you need the very basic dynamic equations and the control properties. So what is the role of stability, the dynamic equations. Okay, in detail, let us see. Let us have a discussion one by one. So there are four types of robo control based on the path. Okay, four types of robo control. What are they? First one is point to point. Point to point control. That is called PTP. Okay, PTP control robo. Next one is continuous path. CP robots. These robots called CP robots. Next, controlled path. This we required the dynamic model, controlled path. Then last one is stop to stop. Stop to stop robo. So what about point to point robo? Point-to-point robo capable of moving from one point to another point. Okay, from one point to another point. So the locations are recorded. So the various from one point to say P1 to P2. So the points are recorded in the control memory of the controller processor. Okay. So the next is continuous for the common applications. Let's see the common applications for point-to-point robo. So the applications of PT-P robo. What are the applications? Component insertion. Component insertion. In the welding, especially spot welding. Then hole drilling. Hole drilling. Machine loading and unloading. Machine loading and unloading. And unloading. Then assembly operations. Assembly operations. So these are all applications of point-to-point. Next is continuous path rule. Okay, continuous path control. So continuous CP, continuous path control robo. Okay, these robots capable of performing movements along the controlled path. Okay, with continuous path from one point to another point. The robot can stop at any specified point along with the controlled path. Okay, so this robot performing movement along the controlled path. Okay, continuous path control along the controlled path. So we can stop the these robots at any specified controlled path at any point. Yeah, at any point we can stop. We can stop at any specified controlled path position. Okay, controlled path. All points along the path must be stored explicitly in the robot's control memory. Okay, so all the points along with the path. Okay, along with the path must be stored. In the control memory. Okay, so the major application of control path is straight line motion. Okay, straight line motion is the simplest example for continuous path control. Okay, it's that simple. So continuous path control robot can also have the capability to follow a smooth curve. Say these robots, the continuous path control robots can also follow smooth smooth path. What is smooth path? Simple straight line motion is a simple application. A simple application. So some continuous path control robo also have capability to follow a smooth path, smooth curve path. Okay, that has been defined by the programmer. Smooth path or a smooth curve path defined by the program. Defined by the programmer. Okay, in such cases, the programmer manually moves the robot with the teach pendant, desired path. Okay, that name is called teach pendant. So teach pendant is teach pendant like a remote. Okay, teach pendant. What is teach pendant? In such cases, suppose the robot also respond to the programmer. So in such a way, he manually moves the robot arm through the desired path, and the controller unit stores a large number of individual points, location, okay, along the path in the memory that is stored in the handheld programmer called teach pendant. Okay, so typical application. So applications. What are the applications? Spray painting. These are all applications of CPC robot. Spray painting, and finishing, gluing, spray painting, finishing operations, gluing, and especially in arc welding applications. So these are all continuous path control robot. Next is controlled path robot. What is a controlled path robot? Controlled path robot. So in controlled path robots, the controlled equipments can generate a path of different geometry, such as straight lines, circles, and joint interpolated curves with a high degree of accuracy. Okay, in these robots can control the equipment, okay, which generates more number of points in different geometry, especially straight line, circles, and interpolated curves with a high degree of accuracy. Okay, so these equipment, the control path robo, in control path robo, the robo equipment, the robo controller can generate the path of different geometry, can generate paths of different geometry. Say straight line, circle, or curve, any curve, especially joint interpolated. Okay, interpolated curves, joint interpolated curves. Okay, curves with the high degree of accuracy. Right? Good accuracy can be obtained at any point along the specified path. Okay, so only start and especially only start and finish points and the path and the path definite function. Okay, definition function must be stored in the robust control memory. Must be stored in the robust control memory. Okay, so robo controller, in the robo controller. It is important to mention that the controlled path robots have servo capability. Okay, especially these robots especially have servo capability. What is servo? With the feedback. Okay, feedback by measuring the position or the velocity, acceleration, anything. So these robots especially have the servo capability. That's why it's called control path. The servo control capability. Servo control. Okay, control capability. Capability to correct their paths by means of feedback mechanism. Correct its path. So this is about the control path robot. Finally, stop to stop robot. Okay, it is an open loop. These controllers are open loop control system. Open loop control system. Position and the velocity of unknown controller. Okay, it is an open loop system. Position and the velocity are unknown to the controller because this is an open loop, no feedback. So no sensing mechanism, so that no position and the velocity are unknown to the controller. Okay, unknown to the control. Okay, on-off commands. So these robots obey mainly for on and off commands. On or off commands stored as a value states. On and off commands stored as value states. End travel set by the mechanism. Okay, end travel set by the mechanism. So end travel set by the mechanism. Okay. Next is servo command based flexible servo system. Okay. Next type is servo command. So command based flexible servo system. What is flexible servo system? So the servo command interface is located between a motion control and the servo control. So motion between motion control and servo control. So there are two types of control involved here. One is motion control and another one is servo control. So the servo command based flexible servo system is located between motion control and servo control layer in the control system. Okay, see, let's see the layer is presented here. So teaching process here. So trajectory control. Better we will continue here. So this is happening in most of the robots. This is motion control. Next is the servo command is located between motion control and servo control. Okay. So this is a generalized robo control structure in the trained robo in the industries. Okay. See, this is teaching process. That is, say, we can have a teach pendant. First stage is teaching processing. Say, for example, teach pendant. The name is teach. So first, the robo for any robo, say ABB robo, Allen Bradley robo has different language. Similarly, there are different type of robots are there. So each robo has its own language. It depends on the manufacturer. So feeding is robo language. Then point data. We normally feed these two input to the teaching pendant or teaching processing stage. Point data. So what are the various path on the path points on the control, right? So this is a teaching point. After this processing, teaching point, then trajectory control. Trajectory control. So it generates trajectory. So trajectory generation. Trajectory generation. Next, hand trajectory. Trajectory. Next, motion control. Motion control. So coordinates transformation. These stages comes under our robo kinematics, robo direct forward kinematics, reverse kinematics, dynamics. So everything comes in this motion, robo motion control. So it generates coordinates. Coordinate transformation. Then servo command. Finally, servo control. So here multi-axis actuator control. So servo reference mode, okay, actually this stage happens servo reference servo mode control parameters etc. feed here. Okay, so the servo reference, servo mode, what type of servo mode, everything is feed here. So it is in the servo command. So what I inform here, so in the servo command based mode, the motion control, the servo command is between motion. See, servo command, this servo command is between motion control and servo control capacity. Okay, so then the servo control has different mechanism. So this is actually servo control operates the each joint mechanism. Say multi-axis actuator control means actually suppose there are many axes. Okay, so for a one joint can have 3 maximum axes, because in the world space coordinate you can have 3 x, y, z. Even at the wrist we have 3 joint motions. What are they? Ja, pitch, ya, roll. Okay, pitch, ya, roll. Okay, these are all joint motions. So each joint has different many axis control mechanism. So basically, you see, this is single actuator. Okay, this is the actuator. Normally electrical actuator for joints, say we say DC motor, either torque or speed control, torque or speed or position. So this picture shows a single joint. Okay, it is a single joint or single arm, single joint. Joint is the exact name. And represent here joint, single joint actuator. Okay, actuator. So what are the components in a single joint? Say normally the DC motor is equipped with gear mechanism. Okay, mostly gear is employed with the robo to have an accurate position and the velocity control, as well as if we attach a gear, it can generate more torque. Okay, capable of more torque. You see, this is the electrical motor. This is the coupler. So electrical motor, so which has electrical supply. Okay, so DC electrical supply. This is a coupler. Coupler has V and J coefficients. Okay, so the motor has inertia since it is rotating. Its shaft has moment of inertia. So this is the connecting rod. So the connecting rod is connected with another coupler. So coupler along with the gear 1 and the gear 2. So these gears, there are 3 different gears have transform 3 different positions. Okay, so there are four gears, so which transform the position to get the required position of the controller. So actually the servo, from the servo command, interpreter, say from the servo command, interpreter, okay, says servo command, okay, interpreter. So servo command, Okay, servo command is given here. Command is feeding to the servo. So here there are many reference system. So I am representing it as a servo reference queue table, SRQT table. Okay, servo reference queue table. Then next one is control parameter table, CPT, control parameter table. Then the third one is servo variable table. Servo variable table. Okay. Then these three command goes to the next stage called multi-axis digital servo system. Multi-axis digital servo system. Okay, multi-axis digital servo system, which controls position and velocity, torque. These are all okay. Torque servo, position, velocity, torque. Then state variable, state variable, state variable deduction. Okay, deduction. So torque, this is torque servo. Clear? So this goes to here. From here, the actuated torque controller operates here. Okay, actuator torque controller, which requires feedback from the sensor. Feedback from the sensor, then actuator, then robo mechanics. Robo mechanics with the dynamics. Okay. So this is a control. Actually, this is servo reference table is a bidirectional. This is unidirectional. This is servo variable table, gives the data to the system. So this is it is in the forward. This is also bidirectional. So from the multi-axis digital servo system, torque reference, tau reference is here. So this is actuator torque controller. Actuator torque controller. Sensor gives feedback to the multi-axis digital servo system. So it is from the actuator torque controller, actuator robo mechanism. Okay, mechanics, robo mechanics. Okay, these robo mechanics are controlled by the controller. Okay. Controller. Understand? So IO input output control based on the data. So this is the overall servo command based okay, flexible control system. Flexible control system. This configuration has two main tasks: the control command interpretation and the multi-axis digital servo system processing are executed in the system. in servo command of interpreter, a published servo command is analyzed, and the servo reference queue or the control parameter table, this control parameter table gives the information to the digital servo system. Okay, so the control parameters written on the common data table, such as servo control mode, the such as servo gain or feed forward gain, or so in future coming classes we will discuss about the gain, okay, determination of controller gain. So there are different type of controller: feed forward, feed forward, feedback, feedback controller, then proportional controller, then proportional derivative controller, and proportional integral derivative controller. Okay, there are different modes. Also, we are going to see the uh, different type of control called force control, impedance control, position control, force control, torque control, impedance control, Similarly, there are different controllers. Okay, control different controllers. Let's see from the teaching point. Okay, first trajectory interpreter. Then coordinates transformation. Let's see how it happens. So far we have been studied different coordinates, transformation, different type of dynamics, kinematics, etc. Right? See, this is teaching point data. Okay, trajectory interpreter, coordinates transformation, okay, coordinates transformation. So from the trajectory, so coordinate, whether x coordinate or y coordinate, so coordinate transformation, x coordinate, y coordinate, z coordinate, etc. Okay, it generates required position. So joint angle, say theta. Okay, it generates. So coordinates transformation means from x to theta. So what is it? From, we know x, so we have to generate theta. So this is inverse kinematics, right? Forward kinematics means knowing theta 1 and theta 2, theta 3 joint angles, we can find the world space coordinates. So that is forward kinematics. So here what happens? Inverse kinematics. Inverse kinematics plays a vital role in the coordinates transformation. So theta generates. So these theta also fed to robodynamics model. Robodynamics model. Okay. So after the robo model, from the model, it fed to again the servo command publisher. Okay, this is servo command publishing. Servo command publishing. So robo generates actually from the in this point, from the coordinate transformation, servo publishing okay. So from all the stage, it is getting a feedback data. So to the robot dynamics, feedback data. Feedback data. Okay. So what robo dynamic from the robo dynamics model? What are the parameters transferred to servo command? Okay. So J E. Okay. E of error in the position. Okay, so it is generating in terms of Jacobian coordinates. So error E of theta, then theta cap of theta, right, or G. Okay, G of theta. So this thing generated by the robo current positions. So from the servo command, flexible servo system. So this is flexible servo system. So we can classify the various positions. Say this position called trajectory control. So this stage called trajectory. This stage called trajectory control. Trajectory. From this stage to up to the servo command stage, this stage called motion control stage. Motion control stage. The final one is servo control. Servo control. Right? This is the overall robo control algorithm using the servo command interface. This is the robo control algorithmic stage. Okay, algorithm using servo command interface. Servo command interface. Clear? So this is so far. Say the servo command based flexible servo system has the three stages. First one is trajectory control. Trajectory. As I said earlier, the motion control is between servo control and see here the servo control is between motion and the servo control. Servo command. The command is between servo control and servo. So in between there are three stages: servo control, trajectory control, motion control, and servo control. there is a stage, algorithmic stage between motion control and servo control, that is called servo command interface. Servo command interface. Okay, what is servo command interface? This is overall schematic. So how to teach, generate the path. So teaching processing, trajectory control, then motion control. Okay, so then servo command. This is a servo command interface. Then servo control. Finally, servo control. So what is actually required for the servo control? There are different multi-axis control system. So each axis has its own dynamics. So most of the robo involved with the DC motor and okay, so DC motor for mostly torque DC torque motor. Okay, that mostly called DC torque control motor. Torque control motor, because the torque control motor is involved with motor plus gear system. Motor plus gear system. Gear arrangements. So, what is actually in the servo interface? So, in the servo interface, so servo command interpreter, then different tables, then multi-axis digital servo system. It also generates the state variable. Then reference torque is fed to the actuator torque controller. So sensor, this is a sensor to give the feedback to the multi-axis digital servo system. The actuator, I misread here, sorry. The actuator gives command to the robo dynamics. Also, the controller I/O also gives the information to the robo mechanism. So there are different controllers: feed forward, feedback, proportional controller, PD controller, PID controller, torque control, and the impedance control, force control, etc. So we will see one by one in future classes. So what is in the torque planning? Okay. So the torque torque planning data. So your the trajectory interpreter is in the trajectory control stage. Then the next stage is motion control. Then final stage is servo control. This is the robo control algorithm using servo command interface. Servo command interface. Next we see